Okay guys, now let's try and understand balancing of redox reaction. Initially, let's try to see how can we find out valency of unknown element. Now suppose potassium dichromate is our example, K2Cr2O7, where we know potassium, we are supposed to know valency of potassium and oxygen, and which we know oxygen is -2, potassium is +1. Two of them are there, two of potassiums are there, so it is +2. 2 into +1 is +2, and 7 into -2 is -14. And this, since two elements are there, so we put it as 2x. X is a variable which is to be found out. So we just now, and apart from that, there's no valency over here, no charge given over here, so we assume it to be 0. So whatever is there, +2 plus 2x plus into -14 is equal to 0. Is equal to 0 is to be assumed. Alright, is equal to 0 is to be assumed. So when we assume that, this becomes 2x minus 12 is equal to 0, or x is equal to 6, and so the valency of chromium is +6 over here. It's +6. Alright, when 12 goes this side, it becomes +12, and divided by 2, +6. Fine. Similarly, if I take hydrogen peroxide, we know hydrogen is +1, oxygen, so no charge given here, it is 0. So this has to be -1, -1. So here O is -1, O is -1. Now, whenever we talk about balancing of redox reaction, there are two methods. One is oxidation method and one is half reaction method. Let's check out oxidation method. In oxidation method, suppose this is the reaction which is given. Our first job is to find out the oxidation states of each element. So we find it out the same method that we saw here. So MnO4, O we know 4 is there and -2, so it has to be -8, and they have given charge is -1, so +7 -8 is -1, so Mn has +7 as its oxidation state. Fe already given, it is 2, so it is 2. Mn already given, +2, Fe already given. So first of all, we have got to find out oxidation states of each element, and then check out where does reduction and where does oxidation occur. Now when we check out Mn to Mn over here, it is +7 here, it is +2, so reduction or gained 5 electrons. Alright, so reduction occurred here, from here to here. Now when we talk about this to this, it was +2 here and +3 here, so obviously oxidation, loss of 1 electron. So 1 electron loss here, 5 electron gain. So there's imbalancement of electron in reduction as well as oxidation. So first job is to balance that. How do we do that? So Mn +7 gained 5 electrons, Fe2 plus lost 1 electron. So we have got to balance this gain and loss of electron. So we have got to multiply this with 5. Second one, we have got to multiply it with 5, so that 5 electrons gets balanced. So electrons gained is equal to number of electrons lost. Number of electrons gained is equal to number of electrons lost. So we jot down the reaction again, but now what do? We multiply this reaction with 5 and write it that way. So yes, so we have balanced electron by this method. Loss and gain of electrons, balanced. Next job is to balance O atom, oxygen atom. We have got 4 O over here, which has to be balanced by water. So what do we put? So what do? We put in 4 water molecules over here. Just for our clarity, we know these are all in aqueous state, so we have put in aqueous, whereas here it itself is a liquid, so we have put in L over here. Fine. So we put in 4 water over here, so 4 into 1 oxygen, that is 4 oxygen, and this 4 oxygen gets balanced, so oxygen is being balanced. Now what do? What finally is to be done is the charge and hydrogen are to be balanced. Charges and hydrogen atoms to be balanced. How? By balanced charges and hydrogen atom by H plus on the side where required. So when we check out here, it's very clear that here we have got 8 hydrogen, here we don't have any hydrogen at all. So we put in 8H plus. Now on putting 8H plus, we find everything is balanced. Just let's check out charge. Now Mn2, so 2 plus and 3 plus into 5, that is 15 plus 2, 17 positive charge over here. Here it is 8, and again 5 into 2, 10. So plus 10 plus 8 is 18, and minus 1, 17. So 17 charge, 17 plus over here, 17 plus over here. Charge balanced, proton balanced, all elements balanced. And another information that you get after balancing this reaction is that this reaction is an acidic medium.